So what I want us to do today is, I'm trying to, here. See, the ones I highlighted in yellow are the things we have been able to cover ourselves. Okay, let me see, where is this Zoom thing coming from? Okay, I thought someone was trying to come in. Okay, so what we are trying to do is this. Okay, one sec, please. This one. Here, this one. Effect on changes in data. All right, so that part was not included in what we have done so far. So I thought, okay, we need to do that. And also because I found 2 to 3 past paper on the idea. So what will be the effects on any change made to a particular set of data? For example, if you had the original set of data, if you had 1 to every number, you subtract 1 from every number, you multiply every number by 1, or sorry, not by 1, by a number greater than 1, or divide. What happens to the mean and standard deviation? So that's what this is about. So I'm going to want you to bring out your calculator. If you do not have your calculator, it's going to be a calculator investigation. Okay, you still remember how to do the statistical measures, isn't it? That we used in school. Do you still remember? Okay, great. So I'm going to want you to start with this activity. So these are the set of data that we are working on. I want you to find the mean and standard deviation using your calculator. So you might write something. Okay, Clarissa is trying to join. So you might write something on your paper or something like that. Clarissa, can you hear me now? Please say something.
Yes.
Great. Can we see your face as well? Okay. Okay, John using my phone. Okay, that's fine. So if you're not able to use your camera, it's fine. Okay. So what we are trying to do, Clarissa, is we want to discuss the effect of change in a set of data. Can you hear me?
Yes.
All right. If changes are made to a particular set of data, by changes we mean if we decide to add 5 to every, take for example, we try to get everyone's salary, okay, in a particular company, and then a particular bonus was given, so everyone get a bonus of $5,000. What do we need to recalculate the mean and standard deviation, which of course can be used to calculate the variance, or are there ways we can just do it directly? So that's what this investigation is about. So I've asked everyone to bring out their calculator, put this set of data in your calculator, let's calculate the mean and standard deviation. Okay, so write in your notebook, 1, just write mean standard deviation. Is that your second device, Clarissa?
Um, I'm not sure.
Because I just accepted another device now. But anyway,
I'll check if it works.
as long as you can hear me, it's fine. So we want to calculate the mean and standard deviation, everybody, for this data. So write number 2 also in your notebook, and add in number 2, add 5 to each of the data. Of course, you don't have to write it down this time. You can just, by looking at number 1 on the screen, you could just put this in your list 1 column on your calculator and add 5. So you have to put in 9, 7, something like that. Understand, everyone? So you don't have to write it out yet. So I want you to print out this worksheet later and then write your results. And that is what I want you to give back to me when you come back to school. Okay, but for now, just write in your notebook. You can write the topic, effect of change, effect of constant change in data, investigation. You write the date so you remember what you did. It depends on how you present in your notebook. So just write question 1, mu is equal to this, sigma is equal to that. Question 2, you can skip question 2 since I don't want you to write the data out yet. So you can write 2 and leave it blank, then 3. So do the mu and standard deviation. Question 4, I want you to write a comment, what you notice about the mean and standard deviation. So you go to question 5, you add 6 to those, subtract 6 from those data. You do the same mean and standard deviation. You come up with a comment. You multiply the data by 3 in question 8. Okay, in question 8, you do the same mean and standard deviation. Okay, you write a comment in question 10, and so on and so forth. Then in question 11, I want you to try dividing by 2 because it's easier to divide by 2, just bunch of 0.5s. That's why I chose divided by 2. Let's find the mean and standard deviation. Actually, multiplying by half is the same as dividing by 2. So I will expect the result of question 11 to be similar to the previous one. I think question 8, I don't know. So tell us what you notice as well. Then I want you to complete this table based on your observation in question 14. And that's all about investigation. The other part is on the second page where we solve, okay, actually come starting from here, where we solve some question using the result of this investigation. One sec, please. Don't forget we are dealing with population standard deviation. So when you check your calculator, you are working with sigma, not S. We differentiated that in class. The sample population will be divided by n minus 1, which you're not to worry about for your IB exam. The exam will only be on the population measures, not the samples. So in your calculator as well, you go with sigma. It's well labeled in your calculator, sigma x and sx. So just go with sigma. That's why I chose the sigma symbol as well. So what I want you to do later, you work on that while I eat food. What I want you to do is send me a picture on WeChat if you are able to after you get your table of summary. In particular, I want to see the comments, or maybe just everything. Just send me the pages as you work in your notebook, okay? Just send me that. Any questions from anyone? No? Okay, so everybody got what to do. Krista K, Krista C, any questions? Nope. Okay, great. Krista C. Okay, great. Callista? Perfect. Nakita, questions? Clarissa, I can't see you. Do you have a question?
No.
No. Okay, great. So let's get to work, everyone. I'll leave this on the screen. So Karen and Ethan Chang will be watching this video later. So please make sure you also do the practice, this investigation, as if you're in the class before we start talking about the answers. So I'm going to pause the recording of the video so we do not just record unnecessary aspect of the video for the video. So once we are ready to share feedback, I'll start the recording again. So that means Karen and Ethan should also pause the recording and get into this point, and they can resume after they have also completed up to question 14. Okay, before watching what follows next. Thank you. Okay. So let's have 2 more minutes to attempt. For those that are home, that are watching this later, after the investigation, you are to attempt question 15 and question 18. So attempt 15 and 18, pause the video again before you watch what we're doing. Mr. Chang and Miss K, don't forget that. Okay, this is good, Lily. For the variance, you find the non-standard deviation. The new variance will be, yes, this is correct, Lillian. Good job. Nakita, checking your work. 15. Nakita, could you write mean summation fx over summation f, something like that? But this is okay as well. I'm just like explaining what you're doing basically. But for the other one, new mean will be the old one. Okay, times that. Perfect. New variance. So like I said, where does times 2 come from? I don't understand. So you need to explain with standard deviation, not variance. Remember, the investigation is on standard deviation, so you need to bring in the effect on the standard deviation, which consequently leads to the effect on variance, not just the variance directly. That is less confusing and more explanatory, okay? All right, it's 12:09. By 12:10, I'll do the correction. We all look at it together. So hopefully maybe by 12:15, we can close the class. So Karen and Nakita and Mr. Chang, please make sure you do this before you watch the next part of this video. So tomorrow we will begin with correlation and regression. Okay, Calista, yes. Good job. Calista, also learn to use the symbols. Mean as mu, variance as sigma, standard deviation as sigma, variance as sigma square, something like that. Okay, get used to the symbols. New standard deviation. Okay. The only problem I have with your sigmas is it look like 0 or like Olaf sometimes. We don't want to do Olaf. This is sigma. Okay, so just take note of this. Krista K, what you sent me looks like theta is equal to 3. It doesn't look like sigma is equal to 3. Okay, so just make a change. Okay. All right. Let's do the correction together. Together. Krista, I'm going to share your worksheets for the summary. Can everybody see what I'm sharing right now? Krista's report. Can everybody see it? Good. Okay. So I'm particularly sharing that because of those that are home, those that are watching later. So you could see that clearly the standard deviation does not change, but the mean increased by 5 when everything is increased by 5. Okay, and that is a summary for this part. which is 14b, isn't it? Okay, so if this data, xi is the original data with mean mu and standard deviation sigma. Okay, so if every data is increased by 5, that is the meaning of the symbol, every xi is increased by 5. Then the mean is increased by 5, but standard deviation remains unchanged. So that's correct. So the mean also has a difference of 5. Now, Krista, you could write by saying the mean increased by 5 while the standard deviation stays the same, like you said. Okay, good job. Now, if you subtract, the same thing is experienced. Okay, so if 6 is subtracted, oh, the mean reduced by 5. Okay, the mean reduced by 5. Don't use the word different. Oh, the difference is, what do we mean by different? Is it increasing or is it decreasing? Krista, can you hear me? Okay, good. Is it increasing or decreasing? You want to mention that, okay? Because it's about, oh, if you increase it by a certain number, don't just say difference could be it's reducing as well. So you really want to be specific. Standard deviation still remain unchanged. Then when you multiply, then you realize the mean is multiplied and the standard deviation also is what? Multiplied by 3. So, and that is the summary here, the second line. When each set of data is multiplied by A, the mean is multiplied by A, the sigma is also multiplied by A. And when you divide, which is like multiplying by half, then you realize the same thing. The mean has dropped by half, the standard deviation also dropped by half. So remember, K is a number greater than 0. Okay, I didn't put that condition. Sorry, A is greater than 0. So A could be 1/2. So it works for both multiplication and division. Understand? And this is just a combination of two properties. So if each of the data set is multiplied by a constant and then A is added. So for the fact that when it is multiplied, it affects both standard deviation and variance. But when K is added, only the mean is added, is increased by K. This remains this. Does that make sense, everyone? Each of the data set is multiplied by A, and then K is added again. So there are two things. So we know that when it is multiplied by a constant, both the mean and standard deviation are multiplied by the same constant. But when a constant is added, only the mean is affected. The standard deviation remains the same. So the first operation, multiplication, affects both of them. The second operation only affects the mean. That is why you have this summary table. Understand? Very good, everybody. Wonderful, wonderful. So now, let's take a look at question 14. Question 14 says, 15, my bad. There are 8 items in the data set. The sum of these items is 48. So we want to talk about the mean. Eight items in the data set. So after this, we can all go and eat food, of course. So question 15. So our mean is simply the summation of all these xi, or just summation x actually. Just write summation x is fine. Divided by n. Okay. According to the question, the sum of this item is 48. So divided by 8, and that gives the mean of 6. That's the first part of the question. The second part of the question says, the variance of the data is 2. So the second part, variance is sigma square. Sigma square is 2. This implies that sigma, you don't need to write the word standard deviation, we will understand. Okay? The question now says, each data set is multiplied by 3. Find the new mean. The new mean. So I could say mu2, something like that. Or you could just say new mu, it's fine. Will be the old one multiplied by Multiply by what? Multiply by 3, and that gives you 18. You don't need to calculate anything. Then the next and the last question, the new variance. So the first thing is to find the new standard deviation. When product happens, you multiply by both the mean and standard deviation. So which means the new standard deviation is 3 root 2. And consequently, this implies that the new variance is going to be the square of the new standard deviation, and that's how you get the 18. Okay, so please be as explanatory as possible. Use symbol, just to show that actually you understand the notation stuff as well. Okay, if you don't want to use symbol, of course, write statements. Don't just write 48 over 8 is equal to 6. Okay, show off a little bit in terms of using symbols. Be OCD a little bit. Miss OCD, that was for you. All right, question 18. So I share the question just so we'll know what we are talking about. So question 18 is this. A data set has n items. The sum of the items is 800 and the mean is 20. Standard deviation of this data set is 3. Each value in the set is multiplied by 10. Find n, write down the new mean, and find the value of the new variance. So it's similar to what we have just done. So let's go back to the board. So question 18. A data set has n items. The sum is 800. The mean is that. So the mean of the data set, population mean, is equal to addition of everything divided by n. So your mean is 20, 800 divided by n. So this implies n is equal to 800 over 20. Of course, some of you have done this. You sent me your result as 40. So good job. Good job. My 40 looks horrible. Sorry, I'm trying to be OCD. I'm not competing with you, Peter, don't worry. You're the boss. Write down the new mean. Write down the new mean. The new population mean, since each data set is multiplied by 10, it's going to be 6 times 20, which is 120, right? And finally, it says write down, right? So it's not like we need a particular calculation and it's just 1 mark. So this is enough, okay? But the other one, if you notice, is 3 points. So you don't just want to write 3 root 2 squared, okay? That's the reason for going through the route of standard deviation. So since each data set is multiplied by 10, in the old standard deviation is 3. Okay, so we know that, yes?
The mean should be multiplied by 10.
Oh, what did I do? Times 6.
You multiplied by 6.
Thank you. Is that Crystal? Is that Crystal? Was that Crystal or Callista? Oh, that was Callista. Oh, you guys are confusing me already. Okay, so that means I didn't get enough sleep, but you got enough sleep. All right. So our old standard deviation is 3. So what we know is that sigma is equal to 3. You see, the way I write my sigma too can be horrible. But what is not nice is to write sigma like this, or to write it like Olaf. Please try to avoid that. All right. So if that is our old standard deviation, then the new standard deviation will be 10 times the old standard deviation. You could call it sigma 1, sigma 2 if you want. You get? If you could just use the word new and old. So that means our new variance is going to be 30 squared, which is equal to 900. So it's 3 points, right? So you really want to show us this, you want to get the right method and the right accuracy, and things like that. I'm sure almost everybody got this already, and those that are watching later now understand what we want. Brandy, I just saw your message. I'll check later if still needed. I'll give you feedback if still necessary. Oh yeah, I think it's something we have done also, so you can confirm. Your mean, you use X bar. We are talking about population mean and population variance here. So just stick to the mu and sigma. Okay. Any questions, please? All right. So I leave you with the rest of the questions in the worksheets. Very sweet, sweet questions. Sweet, 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 sweet question. So it's the same thing again and again and again, right? It's the same thing. A data set has a mean of that, standard deviation of that, 5 is added. Of course, this is easy, okay? These are from IB exam, 17 to 19 are from IB exam. We've just done 18 together. So please make sure you attempt 17 and 19 and write the comment here, okay? If you're not sure of what you have written, please send me a WeChat message. With this, we've come to the end of today. Thank you very much for coming, and I'll see you tomorrow. Okay, any questions, anyone? Okay, bye. Enjoy the rest of your day.